Okay, so should be stuff that you do know, but I just need to make sure that you are aware of it. So before we move on to surface geometry, we'll just make sure we go through this up. So polygon. Polygon is a closed plane shape with straight sides. We talked about that last lesson. Poly means many, so that's the general name. So a regular polygon, if something is regular, then all sides of it are the same length. Okay?
Sorry, remember when we were talking about how I said a non-polygon? A nollygon? I meant an irregular polygon.
Roger that.
A circle is an irregular polygon?
No, darling, it's not a polygon.
Exactly. So it's an irregular polygon.
No,
Oh, no.
It's not a polygon.
It's a nollygon.
It's a non-existent polygon.
It's a circle.
Alright, okay, names of polygons. So they have special names. What's a three-sided
Triangle.
Okay, let's fill them in. Four sides.
Quadrilateral.
Oh wow, Julia is a tad loud. Oh gosh, that's not interesting.
Hey.
Five sides.
Pentagon. I mean pentagon.
Okay,
Wow.
hexagon.
I was gonna say hexagon. So I was saying hexagon at the same time.
Six sides.
Hexagon.
How do you spell quadrilateral? The quadrilateral.
Now, we could have fights for the next one. US and UK are different.
Septagon.
Heptagon.
It's a heptagon.
Heptagon.
Dang it. I say something else.
What is it in the UK and what is it in
It's
So that's UK, US, sometimes they call them septagons.
I call it a septagon.
I call it a hexagon.
I call it septagon. Well, you're gonna have to start calling it.
So if I want to heptagon in the test, we'll get it.
Yes, you would get it wrong. I'm going to get you to get into the heptagon.
But
Okay. Why is it
Because I don't think a septagon is actually... Anyway, I say this in the US,
yeah, I
but
knew that one.
they may not even.
Don't know
It's a
what
heptagon. 8 sides.
Octagon. Right, you get it. I'll get this one.
Nonagon.
Oh, not yet.
Yeah.
No. Nonagon.
9 is non.
You have to say 9. You have to say the number first, and then we have to say it.
10.
Decagon. I got it.
Decagon.
Decagon. I said it.
You said decagon.
No, I said decagon.
What's 11?
11.
Electagon.
No, it's a special.
Deptagon. Dudeptagon.
Dudecagon.
No, dodecagon. It's a hendecagon. No, she read it. That's cheating.
I did not.
What?
It's a hendecagon. So the decagon bit is the 10, and then the hen is the one additional one. Okay, so any of you Latinos, that should be helpful for that. It's a hendecagon. And
What did you say? Dodecagon.
Dodecagon.
No, it's dodecagon. You said dodecagon. That's wrong.
I said dodecagon.
No, you did not. You said dodecagon.
I
That's
literally
wrong.
went before you.
so I got colours up. What's going on?
I'm a gangster.
Dodecagon.
Alright, so we've fought over the names. That's a bit weird. So, interior angles of a polygon. So sometimes you were asked about the interior angles and the exterior angles. So I've said we're going to investigate. Well, I guess we are going to investigate. So what I would like you to do, so we're talking about, when we're talking about interior versus exterior, interior angles are these ones here. Remember we talked about the exterior angle of a triangle yesterday?
Yeah.
So the exterior angles would be that if you were to extend the lines of each of the sides of the polygon, and when I say this, I mean in the same direction. So can you see all of these lines are extended in a clockwise direction? What I could have done, if I'd had my pentagon, I could have extended them all in this direction. And these would have been my exterior angles. Okay? So as long as my shape is extended in the same direction, they would be classed as my exterior angles versus, and then obviously the ones inside are my interior. Okay? We talked about this a little bit yesterday with the triangle and quadrilateral. So what we're going to do is we're going to start chopping our shapes up into triangles. Okay? So we're going from a vertex to a vertex. And in the table, you're going to complete the information here. So, number of sides, we can fill that in before we even start. So we know this is a 3, 4, 5, and so on. You're going to tell me how many triangles there are. So obviously for the triangle, there's one triangle, and the angles add up to 180. For the quadrilateral, we talked about this yesterday, there were 2 triangles,
360.
so 360. And so you can just fill in the rest of this. It will take you like 2 minutes. So I don't think you even need to find the triangles and you can start to spot the pattern. Alright, so I trust that everyone's got those correct numbers in. Okay. Now there's a formula we use to find the sum of the interior angles. Okay. What we do is we focus on, we say it's a general formula and we say it's got n sides. So the n can obviously change. So if it was talking about a heptagon, n would be 7. If it was a pentagon, n would be 5. So what I want you to have a look at is there a connection between the sum of the interior angles? How do you find the sum of the interior angles?
You do the number of triangles times 180.
Good. Number of triangles multiplied by 180. But we don't want to have to draw the shape and find the number of triangles for each one, especially if we're talking about a 34-sided shape. Okay. So, can we now look at the list, that table, and see, is there a connection between the number of sides and the number of triangles? Sharon?
-2.
Good. So, if we say that we have n sides, then our number of triangles, how would we describe that? So Cheyenne just said you take away 2.
N -2.
So you would say it was n minus 2, yes?
Yeah.
Are you with me? And we would multiply that by 180. Now, often we would write the 180 in the front, so it's 180 bracket n minus 2 tells us the sum of the interior.
What would be the n the sides?
Pardon?
What would be n the sides?
Yes,
Why
hence the circled n next to the word side.
Why would you -2?
Because we just said, have a look at the column of the number of sides, and then the column with the number of triangles.
Okay.
It's
like-
like 2.
There are always 2 less, yeah?
Oh, yes.
Well, say if it just gave you a shape. Like, would you just... Never mind.
So if they give you any kind of polygon, yes, you can just count how many sides it's got, take away 2 from it, multiply that by 180, and that's going to tell you what the sum of the interior angles are.
So there's like 2 methods to find the sum of the interior angle. The sum of triangles times 180, and then the n sides times.
Yes,
But
so this one here is obviously a practical situation, but as I said, if you've got a 34-sided shape, you don't want to have to try and draw all of the triangles. That's going to be a tad tedious. So you know that there's always going to be 2 less triangles, so it's going to be 32 multiplied by 180. Yeah? That makes sense? If we were asked to find individual angles, you can only do that if you've been told the majority of them, and you're only missing 1 normally, and sometimes 2 depending if they're labelled with algebra. The only ones that you can find is if they're a regular polygon, okay? Because we know that regular polygons, all of those angles are equal. So if I knew that I had an n-sided shape, then my sum is going to be is going to be 180 brackets n minus 2, and then the individual, I'm going to say here regular, and the individual angles would be 180 brackets n minus 2 divided by n. Okay? So if you've got regular shape, you know that the individual angles would be 180 brackets n minus 2 divided by n, because that's sum divided by how many angles there are. If you just want the sum, it's going to be 180 brackets n minus 2. Does that all make sense?
So to find the sum of interior angles with an irregular shape.
So, yes, so to find the sum of the angles of any polygon, to use this. But for a regular one, if you want the individual ones, you would then just divide that by n. Because we know they're all the same.
Okay.
Yeah? Everyone got that down?
Is that window gonna stay there?
Is that better?
Is that window gonna stay there?
I have no idea, darling. It's not really a useful window, is it? No. It's a bit distracting.
I forgot you split these two out there.
Parking lot.
Parking lot.
I used to walk there every
Someone just said there was a building out there.
I remember Mr. Moore's class when we were counting the amount of like
Somebody
car
said
slots.
yesterday, oh, there's a building out there. Question mark.
They're like, oh, there's a building out there?
Year almost.
Abby, I'm with you, sweetheart. Someone through perhaps is not paying quite as much attention to one else.
They're actually very quick. Okay, so do you know when they're making the walls purple?
No, I think it's just the colour of the boards. I
It's
guess I'm guessing
with drywall like and
Yeah.
thingies that have like
Colours.
stuff on them.
Alright, okay. So we're talking about interior angles, lovely jubbly. Exterior angles. Okay, so as I've said, these are would be the exterior angles. Can you see that interior angles and exterior angles will always be on a straight line with each other?
Yeah.
Yes? So if you know an interior angle, you can find the exterior angle because you know they add to 180.
Yeah.
And obviously the same for the flip side. If you know the exterior angle, you can find each individual interior angle. Now, something special about exterior angles. Oh, this is a boring table to fill in.
Let's not do it.
Basically, no, let's do it.
Oh,
So we can fill in on this 4, 5, 6. Yes, we've got all of our sum of the interior angles. That's copied from the previous side. Okay. This says of each regular interior angle. So how are you going to find this, baby?
180 minus 60.
everyone.
No.
2.
So this is the sum of the interior angles. How would I find the size of each interior angle?
Divide
by
the number of sides.
Times 180 divided by sides.
Yes, remember this is the n minus 2 times 180 already, sweetheart. Yes? And then you're just going to divide by the number of sides. So this would be 360 divided by 4, so it's obviously 90. It's going to be 540 divided by 5, and so on and so forth.
So that's 120.
Pardon?
120.
Divided by sides.
Would that be?
Divided by 5, no. It's 109.
Wait, what would you do? You
108, sorry.
So you just divide 360 by 4.
You do 4 minus 2.
Yeah.
2 divided by 1. I mean times by 180.
Well, this column here is from the previous
Yeah.
table, yes? And then you're just going to divide this number by this number.
Oh.
Now, the size of each regular exterior angle. Well, if I know my interior angle was 60, what's my exterior angle going to be?
120.
120. And I want to know the sum of the exterior angles. How am I going to know that?
60.
Yeah,
The number of sides.
good. Times by the number of sides. So we've got 120 multiplied by 3, which gives me 360. Okay? So you've got 90 here. What would be my exterior angle if this was 90? What do we do? 90. Okay? And then you're going to multiply that by 4 to find the sum of them. Now, obviously, some rounding is going to have to take place at some point. Try and be as accurate as you can, especially when it comes to filling in this column here. Okay. So, I'm not going to fill all these in.
I can.
The important thing is that what do we see about this column here?
They're all 360.
They're all 360. So, actually, it doesn't matter how many sides a polygon has. The exterior angles always add to 360. So, what I want you to do is to think about this. So, if you have a question that asks you about interior angles of regular polygon, that involves a fair bit of work, doesn't it? Yes, you've got to find the sum, you've got to do the n minus 2 times 180, you've got to divide by n, You've got to remember all that. But if you're told if you're looking at a polygon and you want to know something about the interior angles, or if you know the exterior angles, you know that sum is always going to be 360. Okay? So it's way easier to focus on the exterior angles of a polygon and then use that information to find the interior ones. I'm saying all this without actually having a good example to show you. So that's a bit rubbish of me. So let's practice in the textbook, and hopefully there's going to be some good ones in there. Okay?
Yeah.